Okay guys, so this is the last video in the periodic table GCSE topics. This is transition metals. You'll find the information for this. It's very brief again, a bit like the noble gases, not a huge amount to it, but it's still important that you read the notes, read the textbook and have a go with little questions. So we're on page 50 to 51 here for this one. Okay, so again if we just go through this in conjunction with the textbook and your class notes. And okay, so let's get going. Right, so transition metals, okay, the same as we've already done our group 1, we've done our group 7 halogens, and we've done our group O, the noble gases. And you'll see the transition metals, most of you I'd imagine know where they lie in the periodic table. Okay, they are between group 2 and group 3. Primarily the ones that we are concerned with will be the ones in the first row there. Those are the ones that you'll deal with at GCSE. Okay, right, so how do these things, and you have to be able to actually write, and there's a question in your notes, I think it's about a 6-marker question in your notes which you should do. How do these metals compare to the alkali metals? You need to be able to talk about how they compare to the alkali metals with reference to their physical properties and also to their chemical properties. So these are way harder, way stronger. Okay, there is no way you can cut these with a knife. If you look at them, if you look at the periodic table, you look at the transition metals, you'll see things like iron, like titanium, metals that are used in construction, metal that are used to make armoured vehicles, metals that you probably recognise as being very hard and very tough. They're considerably more dense. There's way more metal per cubic centimetre, per volume of space than in the transition metals. These will all sink, than in the group 1 metals. These will all sink when you put them into water. None of them will float like our transition metals, or like our group 1 metals, did. Okay, they have much higher melting points, they have much higher boiling points than the alkali metals, the group 1 metals, except mercury. It's a bit of an oddity, but that's beyond the remit of GCSE chemistry. So again, this makes them useful for things like construction and the building of automotive parts, etc. They've got very, very high melting boiling points. They're very hard, they're very strong. Okay, so if we are comparing the density of them to the group 1 metals, we'll just get a little graph here and we'll just have a look at how you can see on the left hand side there we put the density of grams per decimeter cubed. Decimeter cubed is 1,000 cubic centimeters. Okay, and you can see on the right hand side the going from scandium right up there to cobalt and nickel and copper, the most dense. So there's a huge increase in the density of these metals compared to the low density potassium and rubidium, and the potassium and rubidium are the most dense of the group 1 metals, the alkali metals as well. So big difference. Okay, temperature then at which these things melt, we'll have a look at that compared to the group 1s also. Again, this is another consideration that you need to be able to discuss in an exam question. And you can see there's a massive increase in the temperature at which these things melt compared to the group 1. And again, you've got potassium and rubidium, which is the high melting point group 1 metals on the left hand side there. There's a huge difference. So you might want to have a little think as to why that is, what controls the melting point in these, and what does this tell you about that. So it is, of course, it's the metallic bond, and the metallic bond obviously in the transition metals is much stronger than the metallic bond in the group 1 metals. Okay, so there you go. There's a little checkpoint task that you can do, a true-false task. So maybe you want to pause the video and have a go at that, and then I'll put the answers up. So if you pause the video now. Okay, so there's your answers. So go through those quickly. Those are very simple. They're a little bit about the transition metals, a little bit about the group 1 stuff. So let's have a look at the reactions of these. Again, you need to be able to talk a little bit about the reactions of the transition metals. Okay, compared to the group 1 metals. So there's a general trend for a decrease in reactivity from the left to the right of that in the periodic table. However, there are some exceptions to this rule. So zinc, for example, is more reactive than you might expect, and iron reacts actually quite well with oxygen and water. You would all, of course, know about the fact that iron would rust. And we'll look at a little animation later on just to show that iron is a little bit more reactive than perhaps we might think. So there's a decrease in reactivity as we go across there, with those couple of exceptions that I have just spoken about. Okay. So unlike alkali metals, transition metals do not react strongly with water. Okay, I can put a transition metal in water for quite a considerable period of time and it really won't do anything at all. Okay, copper, for example, is used in water pipes to carry water around the home. So that's a prime example of the fact that it's highly unreactive, doesn't corrode with water. The fact that they're used to make cars, to make buildings, to make bridges, again, is an example of not only their strength, but also their lack of reactivity. You can't build bridges and cars out of metals which will react with air and water. Iron is probably the biggest exception to all of it. And we all know that iron rusts, but it's still used because it's exceptionally strong and it's relatively cheap to make iron compared to many of those other metals that you have there. Okay, so you just have to, with regards to the iron, you just have to protect it. Obviously the anchor on the right hand side of the page hasn't been, but you'll paint, oil, cover in plastic your iron to make sure it doesn't rust. So we're going to have a little look here at how the transition metals compare to alkali metals with regards to their exposure to air, but primarily oxygen. So I'm going to hit play here and the metals will all be lifted out and put into air, lifted out of their little containers. They're sitting in oil at the minute, which protects them from oxygen in the air. So have a very quick look at what happens with them. The first one that will go will be the sodium. So look closely at the sodium first of all, and I'll do this a couple of times so that you don't miss it. Okay, so here we go. So have a look at the sodium in particular. There you can see that it darkened straight away. So I'll just go back for any of those of you who might have missed that. All the others did nothing, but the sodium, if you look at it, darkens. So it has reacted pretty much straight away with oxygen in the air to form a layer. Maybe you can think of what the layer might happen to be. That dark grey layer is of course sodium oxide, and the term that describes what has happened there is oxidized, yes, but also tarnished. That's two terms that you might want to be familiar with. So the other three metals are all transition metals, and we'll look at what happens to them in the air over a period of time now. So we'll look at the calendar at the top right, and we're going a few days, nothing has happened at all. Okay, let's go a few more days through the calendar. And you can see the iron is the only one that's starting to do anything, and it's of course it's starting to rust with the oxygen and the moisture that's in the air. And again, the copper and the titanium are doing nothing. The iron is rusting a bit more, okay, but the titanium and the copper are doing absolutely nothing. Okay, so a good example of their lack of reactivity. Let's look at how these things react when we put them into a Bunsen burner then. So let's take some sodium and pop it into a Bunsen burner. So what you might want to do here, guys, is to just make a little table with the metal in one column, okay, and then just your observations in another column beside it, and then another observation beyond that, which would be, for example, just an explanation of those observations. So let's put the sodium back in again. Let's see what happens to the sodium in a hot blue Bunsen flame. Okay, so let's see what our observations should be. So nothing yet, and then it goes to a yellow flame. So it burns with a yellow flame and it melts. Okay, so there you go. That's your observation for the sodium, and it reacted relatively quickly. Let's take a little bit of titanium here and do the same for our titanium. So let's see what happens. It starts to glow red. Okay, and it burns with a very bright white flame, and it leaves, you can see there, sort of a grey ash. Okay, so that would be your observations for your titanium. Let's do the same for a piece of iron wool here. So we heat the iron wool up, it starts, our observations would be that it will glow a very red colour, red, yellow, orange, okay, and gives off a yellow flame, and it turns into a blacky grey solid at the end. That's your observation for iron. And finally, we've got some copper here. Copper glows red. You can see it gives off a green flame, which is a distinct observation for copper, and it turns from that sort of orangey colour that we had at the start to more of a black colour. Okay, so a good question, or a question that you might need to be familiar with, guys, is what are the new compounds that are formed? And in all instances, whether it be the sodium, whether it be the titanium, whatever, okay, that is the black, and the copper, for example, is copper oxide. The iron that went grey was iron oxide, etc. So you're always getting these reacting with oxygen. Okay, so the transition metals, like all metals, they lose electrons and they form positive ions. Some of them only form one type of positive ion, so silver, always +1, zinc, always +2. But then there's a few of them which are a little bit odd. So for example, here we've got iron, which forms two different types of ions. We didn't meet that in Group 1 or Group 2 chemistry, but iron forms 2+ ions and 3+ ions. There's other ones in there, manganese for example. Okay, not on the GCSE spec, but manganese forms 2+, it forms 3+, it forms 4+, it forms 5+, 6+, and 7+. So it forms a whole load of different ions. Okay, but the iron's the one that you will meet as you go through GCSE. Okay, and it forms +2 and +3. Okay, one of the properties of transition metals is that they're coloured, and you'll find lots of transition metals used in pigments and paints. You'll find lots of them in coloured gemstones, which gives them their particular distinctive colour. Okay, so for example there we've got copper 1 oxide, which is a reddish colour. You can see lots of copper compounds used in paints and pigments, even in school art rooms. Okay, copper 2 however is black. So just by changing the positive charge on the copper, we go from a reddish colour to a blackish colour. Okay, and the number in brackets tells you how many electrons it has lost. You would know that already, I hope, anyway. Okay, iron oxide there with a wrong formula, iron 2 oxide. I'm sure you've picked that up. Should not have a 2 there. It's a black colour. Okay, iron 3 oxide is a red-brown colour. That is very similar compound to rust, and you can see where the reddish colour of rust comes from. Okay, that is the chemical rust, that and water. Copper sulfate is a blue colour. Okay, if I heat it very, very strongly and get rid of the water, so I heat it, I can get rid of the water, it'll turn white, it'll change colour. Okay. Very quick look at some uses of them. So we can already establish they're used in building. They're really strong. They're really hard. They're used in jewellery, gold, silver, platinum. Very unreactive, okay, but very beautiful, shiny, nice to look at. Titanium is used in artificial joints because it's malleable. It's highly unreactive. Okay, so inside the human body, it doesn't interact with what's the environment that it's in there. Okay, paints. Okay. Coloured transition metals used in paints. You've just seen a few of the coloured ones that you might come across. There are many more. Lots of these transition metals are used in alloys to make coins, to make airplanes, okay, to make a whole stack of different materials. Very strong, hard, corrosive resistant materials. Loads of them used in catalysts in industry. You'll see them in making of in the Haber process and the making of ammonia. You'll see them also catalytic converters in cars. They're used in there. Okay. Okay, so let's have a look at our summary activities, guys. So we've got our little multiple choice quiz here, which you need to have a go at. Let me just go to that again. Okay, so again, same as all the other ones. If you pause the video, have a go at it. Okay. So pause the video now, I'll give you the answer. So which of these statements comparing alkali metals with transition metals is true? Again, pause the video and then I'll give you the answer. Okay, why are transition metals more useful and than alkali metals? Again, pause the video. Okay, which of these transition metals do not react with water? Okay, or sorry, does react with water, sorry. Okay, again, pause the video. Of course, the iron rusts. Okay, what does the 3 mean in iron 3 oxide? Those of you who were paying attention a few seconds ago. So pause the video. It's lost 3 electrons when it formed the compound. Okay, which of these are properties of transition metal compounds? They're always white and soluble? No. They are often, so pause the video. Okay, so they are coloured and they are used as catalysts, which we saw a short while ago. Okay guys, there are some checkpoint questions there that you need to do on this, which are on page 50 and on page 51. There's a big question in your notes, of which the answer is also there. That same question is on page 54, question 10 of your textbook. Okay, but it's probably better that you do it in the notes and you keep the answer there, and you check the answer. I think it's on the next page down in your notes. Okay guys, so hopefully that's transition metals covered, and that should be the end of the periodic table topic.